Hello everyone and welcome to my channel. In today's video we have a lot to talk about. We're going to be talking about the parameter, token, PDF and the relationship between the three of them. We're also going to be talking about the token and the cost of the token as a review to what we said in the past. And we're also going to be talking about the RAG, and we're talking about the parameter and the requirement. We're talking about different type of search, and we're also going to be talking about the type of computer that you need for the parameter. A lot of information today, so let's start the video. The first thing we're going to be talking about the parameter, token, and the PDF, just like a very a small clarification about the parameter. A parameter is one learned number inside the model. Each one learned, this is considered one parameter. Versus the token we talked about it before, and we said a token is a chunk of text that the model read or write. And we also said how to calculate the token in the past. If you remember a few videos back, we calculated the token based on the input token and output token, and we'll talk about here a little bit. When it comes to the relationship between the parameter, token, and the PDF, there is not really a relationship between the three of them. However, when you create a parameter give you the size of the model. So the size of the model, if it's big, it means like maybe the PDF you uploaded, it's also big, and that's actually if you have a bigger PDF, so the input will be more, so that will require more token. But like if you try to connect all three together, so there is really no connection here. The other thing here, we're going to be talking about the parameters and the RAG. So I just want you to know that the parameter is how big is the model. So you're going to hear that this model is 1 billion parameter, or this model is 2 billion parameter, and that's, as we said, this is how much information is get processed inside the model itself. And that's why, like when you said like the 1 billion model or 10 billion model, so 10 billion model will require a faster computer than 1 billion model. But if you talk about the RAG, this is the information you provide to the model. So this information, it could be stored in your hard disk. So then you're going to be required to have a bigger hard disk, or if the information is stored into the cloud, so you're going to require like a bigger cloud space. We also talked about the GPT 5.4 when it comes to the API or application programming interface, and we said the cost for the input, we said 2.5 per 1 million token, and the cached input 0.25 per 1 million token. And also we said that cached input is the information it's you already used it in the model, but you're going to reuse it again, and that's called cached input. That's why it's a lot cheaper. When you calculate the cost of the token, so you have input and you have output, and the total cost will be the input token times the input rate, the output token times the output rate, plus any other tools or storage. This slide here, we're just gonna compare the three, the parameter and the token and the PDF. So as we said, like if you have like a 1 billion parameter model, so this is about like 1 billion token, and if you roughly, it will give you about 750 million word. And if you put this word in a PDF file, so it'll give you like 3 million page of PDF file if the files is not so dense. But if the file is dense, it'll give you half of that. And this is for the 1 billion. And if you go with the 100 billion, so you multiply that by 100, but most of the time we really don't go into the 100 billion, at least for what we're going to be using, RFI submills and all of that. So most likely we're going to be going with like maybe like 3 billion model. Now let's talk about the requirement for the parameter versus the RAG. As we said, the parameter is one learned number inside the model. And so the more parameter you're going to need, the more stronger computer you're going to need. So if you have like a bigger parameter, like a 5 billion parameter model, so you have to make sure to get like a very strong processor with a memory. So the CPU, this is the processor of the computer, and the memory of the computer is the RAM, and also not only just the processor and the RAM, but also you have to think very deeply about the video card and also the RAM of the video card. So the GPU and the VRAM also, you have to consider getting like a very strong processor and a lot of RAM, and also a strong video card with a lot of RAM. That's when it comes to the parameter. When it comes to the RAG, as we said, this is like, it depends on if you're actually going to be storing the information that you're going to be providing to your model into your hard disk, then you're going to require a bigger hard disk. If you decided to store it into the clouds, you have to have a bigger storage into your cloud. And it's very important also the security, what type of cloud you're going to be using. So you have to be so careful about the security also of the cloud. Another thing we're going to touch base on today is the open source versus closed source model. The open source is available publicly and can modify it easily, and you can customize it easily also, and also has a very good privacy and a security. But when it comes to the closed source, it is restricted, because closed source is actually, it's controlled by the creator of this model itself. So it's very hard to control it. They give you like a limited accessibility, what you can do, how you can modify it, how you can customize it. And sometimes like a lot of people, they don't like it, because what happened if this company change ownership, so what's going to happen to my model, but the other thing, because it is controlled by the creator, so in most cases you get a very good support. Another thing we're going to be talking about, about the AI power search. There are 3 steps into AI power search. Step number 1 is search for relevant company. Step number 2 is visit trusted source. Step number 3 is to summarize each company. So this is usually the step when you go for AI power search. Since we talked about the AI power search, so now this is an introduction, so we can talk about the LLM reasoning engine. LLM reasoning engine is break down a complex problem into logical steps. So let's see that on the next slide. So based on the prompt you provide, you're going to get a response. And we talked about that before. So if you have like a generic LLM prompt, you're going to get a generic LLM response. So it will give you the summary of whatever information you put there. But when it comes to the reasoning LLM response, so then if you provide like a very good prompt, then the model itself will go through the LLM process reasoning, and the LLM reasoning engine is a specialized AI system that use large language model to break complex problem into smaller logical step-by-step actions rather than simply predicting the next word. What does it mean? It's mean like when using an LLM as a reasoning engine by providing a very good detailed prompt. So then the model itself, it will take your questions and it will take your request and divide it into a smaller steps and take each step or each part of your questions and deal with it separately, and then take all the responses together, put them together, and give you the final response with more details than if you provide the generic prompt. That's why it is very important to take advantage of the LLM reasoning engine by providing a very detailed prompt into when you ask questions. That was a very quick video regarding the parameter, the RAG, the PDF, the token, and also the type of computer you're going to need for what model. Do you have like a 1 billion parameter model? You have like a 10 billion parameter model, and what kind of hardware you're going to need for that, and the storage. And so all of this information is very important for us to understand. So I hope that this video was useful. If the video was useful, please don't forget to like and subscribe, and talk to you in the next video. And thank you so much for watching.